For today's lesson, we are still working on the focus standard of Grade 8 Expressions and Equations, Standard 3, dealing with operations with scientific notation. Our exact topic for this lesson is scientific notation, word problems. Our essential question is, when solving scientific notation word problems, how can we interpret the questions to know which operation to use? So please take a few moments copying the header down, make sure you have today's date, set up your question column and your note column, and when all that's set, let's dive in. So today, we've already talked about all the operations and the rules for them, and so we're going to be interpreting the word problems and trying to decide which operation to use and then go ahead and solve it. And just to kind of cite the sources for this lesson, all the facts and the images that I used is from a site called All About Astronomy, and here's the website if you want to check it out for yourself. So I borrowed some information from their website talking about these 5 planets, Mercury, Earth, Jupiter, Saturn, and Neptune, and looking at 2 different things: their distance from the Sun in miles, as well as the period of revolution around the Sun, so 1 planetary year. You'll notice that this information, the period of revolution, is all in comparison to time on Earth. So be paying attention to that as we work through these problems. So let's take a look at our first problem. Today we'll be solving 4 problems about the planets. So here's our first problem. How much further from the Sun is Jupiter than Mercury? So I want you to take a moment and think about what type of problem is this. What operation are we going to use? Addition, subtraction, multiplication, or division? Since we want to know how much further something is than something else, we're going to go ahead and use subtraction to figure out the difference between those 2 distances. So to do so, we can use the information from our chart. We want to figure out how are we going to set up the subtraction problem. So we're going to take the distance that Jupiter is and subtract the distance of Mercury and come up with our answer. So using our chart, we can fill that information in. Here's the distance for Jupiter from the Sun, according to our chart. And here's the distance for Mercury, and we want to subtract those. But before we can subtract, we have to remember our rules. This should be a red flag to you right here. We have Jupiter is written as a power of 10 to the 8th, whereas Mercury is written as 10 to the 7th. So because those 2 powers are not the same power, we cannot go ahead and subtract until they are, because otherwise we're not properly lined up by place value. So we want to take 10 to the 7th and increase it 1 power. And we're going to do that by moving the decimal from here between the 3 and the 6 over to the other side of the 3. So it's going to look something like this. And again, now that our powers are the same, we want to make sure it's lined up by decimal point to keep our place values all in order, and go ahead and subtract this problem, remembering that we keep the power of 10 the same. Take a moment to do that, and then let's compare. In doing so, we should have gotten 4 and 474 thousandths times 10 to the 8th. And always with word problems, we want to make sure that our final answer is stated in the form of a complete sentence. So we could say that Jupiter is about 4 and 474 times 10 to the 8th miles further from the Sun than Mercury. So let's go ahead and try our next problem. You will want all of this information written down to refer to it, so if you haven't yet taken a moment to pause and make sure this is all written down, you will find that to be helpful throughout this video. So when that's ready, let's move on to our second problem. So now we're looking at time. So a year on Neptune is how many times longer in Earth years than a year on Jupiter. I'm asking you for this problem to go ahead and round the coefficient to the tenths. But first we want to decide what type of problem, what operation are we doing? Addition, subtraction, multiplication, or division. So go ahead and read that problem again and try and decide for yourself what operation, what type of problem are we doing? This phrase right here, how many times longer, those are our keywords that are telling us that, oh, we want to know how many times something goes into something else, so we're going to do division. So now we need to decide how are we going to set that division problem up. Well, we have a year on Neptune. We want to know how much longer that is. We're going to take Neptune divided by Jupiter. I've gone ahead and because we've used this form the most, used the fraction form of division, so Neptune in the numerator, Jupiter in the denominator, using our chart to pull the information we need. Go ahead and set your problem up. Should be something like this. Since both of them, according to our chart, are in comparison to an Earth on year, an Earth year, then we are going to go ahead, we don't have to change anything here. Both of them are in the same form of measurement. So we just need to use our rules for dividing in scientific notation. Remember that we do this in two different parts. We divide the coefficients and find our quotient there, and then we divide our powers of 10 following our rules for the laws of exponents, the dividing rule. Go ahead and divide that out, and pausing the video if you need to, and then compare your work to mine. So if we divide 1 and 648 thousandths divided by 1 and 186 thousandths, we should get 1 and 3,895 ten-thousandths. Then when we do our power rule to take care of the powers of 10, we need to remember that there's an exponent of 1 down here on this power of 10 in the denominator, and 2 minus 1 is 1, so this will be times 10 to the first power, or just times 10. Now that we've done our math to figure out how many times longer a year on Neptune is than the year on Jupiter, we're going to go ahead and write that out as a complete sentence. Something to the effect of a year on Neptune is about 1 and 3,895 ten-thousandths times 10 times longer than a year on Jupiter. Let's go ahead and try our third problem. For number 3, we're saying if the Earth was on one side of the Sun and Saturn was on the exact opposite side of the Sun, what would be the total distance between the two planets? For this problem, because we do not have this information, and to keep it a little more simple, we're going to ignore the diameter of the Sun to determine the distance between the two. So, what kind of problem do we want to do here? Well, since we're determining how far apart they are and they're on opposite sides, then we're actually going to need to combine their total distances from the Sun to figure out the total distance between the two. So this would be an addition problem. So we're going to want to add the distance that the Earth is from the Sun to the distance that Saturn is from the Sun, and you can look up above to your chart to get those values. I have them right here. So we want to go ahead and combine these. Do you see where the red flag is? Remember, with addition and subtraction, we have to make sure that our powers of 10 are the same before we do any work to solve the problem. And since we're using 10 to the 7th and 10 to the 8th, we need to fix that. So we're actually going to fix the one that's smaller, 10 to the 7th. We're going to adjust that and go up one place value. So we're going to move our decimal point over to the left 1 and increase our power of 10 by 1. So our problem's going to look like this once we make that adjustment. Go ahead and solve the answer, and then be ready to check your work with mine. Let's see how our work compares. Remember, when adding and or subtracting in powers of 10 in scientific notation, we keep the power of 10, so we're still dealing with 10 to the 8th. When we combine these two coefficients, we should get 9 and 8,167 10,000ths. So let's go ahead and write a sentence for that. So we'll give our final answer. Let's say something like, if the Earth and Saturn were on exact opposite sides of the Sun, the total distance would be about 9 and 8,167 10,000ths times 10 to the 8th power miles. Let's go ahead and do one final problem. Here's our fourth and final problem. Pluto is about 1 and 200ths times 10 squared times further from the Sun than Mercury. Approximately how far is Pluto from the Sun? And of course, we want to express our answer in scientific notation. But first we need to decide what operation are we doing? What kind of problem is this? So we know that that Pluto is this much times further from the Sun than Mercury, and from our chart we know how far Mercury is. So we should be able to multiply this value times the distance that Mercury is from the Sun. So this is a multiplication problem. We're multiplying. And as I just said, we're going to multiply this value here times the distance that Mercury is from the Sun. So I've gone ahead and set it up here using the information from our problem and from the chart. Go ahead and see if you can solve this problem, and then we'll compare our work. So when multiplying with our powers of 10, we keep the base and add the exponents, so it becomes 10 to the 9th. And we multiply our coefficients, so we multiply 1 and 200ths times 3 and 6 tenths, and we're going to get about 3 and 676 thousandths. So this would tell us the approximate distance of Pluto from the Sun. So as our final answer, we would say Pluto is about 3 and 676 thousandths times 10 to the 9th power miles from the Sun. So that's going to conclude our video for today. Please take a moment making sure that your notes are fully complete, and then come ready to class to work on these problems more.